let's review arithmetic and geometric equations. Okay, so there's a couple types we have to talk about here. Whenever it says recursive, recursive uses the previous term. And the way that we usually write that is f of x minus 1. Okay, so that's what recursive would mean. Explicit means that you can plug in any value. You can plug in any value, any input that you want to get an output value. Okay, so let's talk about what arithmetic looks like. Okay, whenever you have an equation that's recursive, okay, to find f of x, you're going to take the previous one, and then you're going to add or subtract the common difference to that previous term. Take the previous plus 5, or take the previous minus 3. Okay, and that's what an arithmetic recursive would look like. What would a geometric recursive look like? Okay, so his function says take the previous term, okay, but then you're either going to multiply or divide, which is actually multiply by a fraction, okay? So then you're going to multiply by the common ratio. Okay. So when you're arithmetic, remember, that means add or subtract. And you're going to see that in the pattern right there with a plus minus. Geometric means multiply. Okay. It also means divide, but then we're going to multiply by a fraction. So you're going to see a multiply symbol right there. Okay. What does the explicit function look like? Okay. So f of x equals, we usually have a starting value, okay, plus or minus the common difference, and then there's usually some sort of x term, which may or may not be 0. Okay. The explicit for geometric, f of x equals, you have a starting value, okay, and then you're going to be multiplying by the common ratio, and then you're going to have a power, x, which may or may not have something added or subtracted to it. Okay, so let's take a look at some examples and see if we can determine arithmetic or geometric, recursive or explicit. Okay, so for this first one right here, I'm noticing f of x equals 4 times f of x minus 1. So right there, that tells me previous. If we're using the previous, then it's recursive. Okay, I also see that's 4 times previous, and so right there, since this is a multiply pattern, it's geometric. Okay, number 2. E of x equals 5 times x plus 4. Okay, so the 4 is the starting value, and then we're adding 5 a number of times. So this is definitely arithmetic, okay, since we're adding a 5. And since I do not see previous anywhere, this is going to be explicit. Okay, I can calculate E of 3 by simply plugging a 3 into the equation. I can plug in any value. Number 3, negative 3w plus 60. Okay, again, this equation is a little weird. Usually we see the 60 go first, so that's the first term, and then it's subtract 3w times. So this is the first term, and then it looks like we're subtracting 3. So it's definitely arithmetic, and since I can plug any value in, we're not using the previous, this is explicit. Can I find m of 100? Sure, I would plug in 100. Okay, if you can find any term, it's explicit. Okay, let's take a look at this next one right here. I see 3 times 1/2, okay, times 1/2 to the power of. So whenever I see multiply, I know it's geometric. Okay, and exponents mean that it's times 1/2 times 1/2. Now, is it recursive or explicit? Some people get a little confused because it says x minus 1, but it does not say f of x minus 1. Okay, so it's not using the previous term. What this is letting any value of x go in. So if I want to do L of 7, I could plug in the number 7 and calculate the 7th term. So this is explicit, okay, because it's not using the previous, term. Number 5, f of x equals f of x minus 1. Okay, f of x, and this is f of x minus 1. So this is definitely previous. As soon as you see a formula using previous, we're going to call it recursive. Okay, then I also notice that I take the previous and then I subtract 4. If the pattern is to subtract, it's arithmetic. Look at that, the first term is 20. Isn't that nice? The first term is 20. The pattern says take the previous and subtract 4. So it would be 16. I would subtract 4. Oh, that's a fun pattern. Definitely arithmetic. Okay, and the last one right here. S of n equals, this is kind of weird, okay? There's no first term. When there's an invisible number right there, it's 1. So the first term is 1. Then we multiply by 5/7 to the n power. Multiply by 5/7, multiply by 5/7. Since the pattern here is multiply, it's definitely geometric. Okay? And can I find any term? Can I find S of 100? I certainly can by plugging in 100. So that's called explicit. Okay? Explicit can find any term you want. If I ask you to find the 100th term, you can do that. Recursive can only find the next one using the previous. Can you find the 4th term? Yeah, with the help of the 3rd term. If I asked you to find number 100, it would take way too long. I hope this helps.